Good day, students. Welcome to the second section of classes of organic compounds. Last time I was looking at class of organic compounds and I touched on hydrocarbons only. I was discussing compounds in organic chemistry that contains carbon and hydrogen only. So today I'm moving on to these two classes of organic compounds, which are alcohols and carboxylic acids. Right, so today I'm just going to show you what's the functional group in alcohols and what is the functional group in carboxylic acids. First and foremost, you should know that all compounds that fall under the alcohol functional groups, their names will always end up with ol. And these ones, their names are going to end up with oic. So first and foremost, you should know that the suffix for all the names of these ones will end up with ol, and the suffix will be oic. Just like you have vinegar we use in the kitchen, it's called ethanoic acid. So ethanoic acid is a carboxylic acid. But we also have things like ethanol, which is used in alcoholic beverages, ethanol. So ethanol is an alcohol because the suffix is OL. Right. So we also need to understand the fact that for our alcohols, you can have your hydrocarbon part, but there will always be the OH group at the end. For carboxylic acids, you can also have the hydrocarbon part, but you always have this group. Okay, so whenever you have this group, okay, for carboxylic acids, then you actually know that, okay, I'm dealing with carboxylic acid. All right, so let's just look at some examples here. So my R can be a CH3 group, okay, like this. All right, so that becomes an example of an alcohol. Okay, we said that if there's one carbon, we always start with meth. Okay, because it's meth, we are going to have our prefix meth, okay? Because an alcohol is going to be methanol, which is the first member of this family, okay? If we expand our carbon chain, okay, we're going to have two carbons, and then we are going to have two carbons, and at the end, remember, we're always going to have OH, okay? Now, because we have two carbons, it's not going to be meth, it's going to be eth, and this is going to be ethanol, okay? We could actually extend, and then we have three carbons like this, okay? OH at the end, all right? And then, if you look at what we are doing here, we now have prop, okay? In organic chemistry, three carbons is prop, and as a result, we're going to have propanol, okay? Propanol. Alcohol, methanol. Alcohol, ethanol. Alcohol, propanol, like that, okay? So I'm going to migrate from this side of alcohols. Now I move on to that side, okay? Right, suppose my R here is just one carbon, so I'll have like that, okay? One carbon, okay? So we are going to call it meth, but it's an oic, so it's going to be methanoic acid, okay? And then we move a step further. We're going to have two carbons, so let's do it this way, okay? Again, the functional group is always there, and two carbons, we are going to call this one ethanoic acid, because there are two carbons, okay? I want you to notice one thing here. The functional group, okay, for carboxylic acid is what I'm circling. The functional group for alcohols is what I've put in the circle there. And whenever you say functional group, you're looking at the reactive part, the reactive center of an organic molecule. And that's where all the chemical reactions will be taking place. Now, we have done our structure formula, the displayed formula, okay? Let's try and look at the formula for this one. So we can say this one is CH3, okay, OH, okay? If you look at this one, you count the number of carbons, you're going to get C2, okay, H5, OH, okay? If you look at that one, all right, you're going to have C3, okay, H7, OH, okay? Now, as before, we want to try and come up with a general formula for our alcohols and to investigate actually what is happening. How could we come up with our general formula as we did before, where we actually assigned the general formula for our alkanes, our alkenes. Now today we want to look at what could be the general formula for our alcohols. Now let's investigate what is happening here. Okay, right? I have a 3 there and a 1. Okay, so what am I doing? If I want to move from 1 to 3, it appears I start off with my, okay, I can start off with my N, a certain number of carbon atoms. Okay, if I multiply my N times 2, okay, I get 2. But if I add 1, I get 3. And then I'll put OH. Okay, the same applies here. Okay, you are saying 2 times 2, which is 4, plus 1, you get 5, and we have OH. 2 times 3 plus 1, you get 7, and you get OH. So the general formula for your alcohols is illustrated by what I've put in that box there. Okay, we are simply relating the number of carbons and the number of the hydrogens, not including that H, of course. Okay, right. And then if you analyze what is happening to your alcohols, right? We can also come up with the general formula if we want to do that. Okay, let's just write the formula for methanol, for instance. Okay, methanol, you could actually say you have your compound here, which is this one. How many carbons? You have 1 carbon there, okay, and then you have 2 H's here, okay, and you also have 2 O's there. So you have C2, C, number of H's is 2, number of O's is 2, okay. That's the formula for that one. Let's also look at this one, okay. I have C2, 1, 2. How many H's I have? 1, 2, 3, 4. So I have C4, okay, and how many O's? 2, okay, right. So let's trace what is also happening here. All right, if I have 1C, okay, it means the H I'm going to multiply by 2, and the O I'm also going to multiply by 2. Okay, right. So what could be the general formula that we can come up with? I said if you have 1C, the H you are going to multiply by 2, and then you're going to have always 2. So the general formula will be Cn, okay, and then I multiply the H by 2, and then I have O2. Okay, right. That's the general formula. Okay, let me just write it more clearly so that you can see. Okay, if you trace what is happening here, if I have Cn, I'll have H2n, and I'll have O2. This is what is happening. If I have 2, I'll multiply the 2 by 2, which is 4, and then I have O2 there. That could be the general formula for your carboxylic acid. Okay, you need to be familiar with the functional group for each and every organic molecule that you come across, and that will actually help you to derive the formula in future. So whenever I'm given a carboxylic acid, and then they say the carboxylic acid has 3 carbons, okay, how do I go about it? So I'm rubbing, and then just going to do a very short exercise so that you can actually see whether what we're discussing is applicable. I've rubbed everything and I've just left the general formula, okay? We want to practice now, okay? Now, if I'm given, for instance, I'm given an alcohol and I'm told the alcohol has 4, okay, carbons, right? So how do I find the number of hydrogens? I'm going to multiply 4 by 2, and then 4 by 2 is 8, 8 plus 1 is 9, and then this will be the formula of the alcohol, okay? If I have an alcohol and I'm told it's C7, what you simply do is you say 7 by 2, and then that will give you 14 plus 1 is 15, and then you have this alcohol, okay? If I'm given an alcohol C9, I'll simply say 9 by 2 is going to be 18, and I'll have 19, and then I'll have OH. That's how I'm deriving the formula of the alcohols. And if I come here and I'm told there is a carboxylic acid, but this carboxylic acid has 7, okay? 7 carbons. I'll say 7 by 2, I get 14, and then I put 2 there, okay? If I'm given a carboxylic acid, which is 5, okay, 5 carbons, I will say, okay, it will have 10 here, and then 2 there. All right, so when you have done that, what is left is for us to name these, them, okay? This one has 4 carbons, so This one can be butanol, okay? Butanol. And this one has 7 carbons. For naming organic compounds, it's like we're naming shapes. 7, okay? That's why. 6 is hex, 7 is hept. So this one could be heptanol, okay? And this one has 9. 9 is non, okay? So this is nonanol, okay? All right. So that could be our names there. If you also come to this one, okay, all of them are going to be oic, okay? This one is 5, so this one is going to be pent for 5, and it's going to be pentanoic acid, okay? And that one is 7, 7 is hept, so this one is going to be heptanoic acid, okay? So briefly, that is what we can do when we are dealing with organic molecules in the name of alcohols and carboxylic acid. That was the session for today. I hope you have enjoyed, you have learned something when we are naming your organic molecules, and also how to use the general formula to derive the structure formula, the molecular formula, even to go on to draw the displayed formula. This was the session today. Please remember to like my channel, to subscribe to it, and also to share the videos that I'm sharing so that you can also have your friends benefiting. It is always important to learn organic chemistry by drawing the molecules. Organic chemistry is like mathematics. Don't talk about it. When you are dealing with it, draw. Find a paper where you can sketch the molecules. In that, you will learn it better. Because if you just talk about it without drawing it, when it comes to your exams, will be in a position to, you'll not be in a position to answer the questions correctly. That was the session today. Thank you, and bye-bye for now.